Welcome to solverfy.
Okay, so here we start by sorting the points in increasing order of x coordinates, and I've given them all a name. And we're going to divide it out until we have sublists of just 2 elements each, right? So A and B is going to be a sublist, C and D, E and F, G and H, I, J, K, L, and M, N, and O, P. And so then we're going to find the distance between each of those. So standard distance formula, it's going to be that the distance between A and B is equal to the square root of the difference between the x coordinates, so 1 minus 1 squared plus the difference of the y, 6 minus 2 squared. That's going to be 0. So we get the square root of 4 squared is going to be, of course, just equal to 4. So the same thing here, the distance of CD is going to be equal to the difference of the x coordinates. It's going to be 0. The difference of the y coordinates is going to be 8 minus 4 squared. So 8 minus 4 is 4 squared. Take the square root, that's going to be 4 as well. Then we get the distance from E and F. So the x-coordinate, 3 minus 3 is going to be 0. 6 minus 1. So we get the square root of 5 squared is equal to 5. GH is going to be the square root of 1. So 4 minus 3 squared is 1, and then 3 minus 10 is going to give us a negative 7 squared. So this ends up being equal to the square root of 50, 49 plus 1, which is 5 times the square root of 2. The distance from I and J is going to be 4 again, because the 5 minus 5 equals 0, and then we get a 5 minus 1. So 4 square root of 4 squared is 4. The distance from K and L is going to be the square root of 1. So 6 minus 5 is just 1. Squared is 1, and then plus 2 squared. It's going to be 4, so this is the square root of 5. The distance from M and N is equal to, in this case, it's going to be 7 minus 7 squared, which is 0. 4 minus 1 squared is 9. So this one's just going to be square root of 9 is 3. And then lastly, the distance for O and P is equal to 8 minus 7 squared. So that's 1 squared is 1. Plus the 6 minus 9 squared. So it's going to give us a negative 3 squared. Of course, it's 9. So this is the square root of 10. Okay, so then now we're going to do something similar. But in this case, we're going to consider the distance between the larger subsets. So A, B, C, D, E, F, G, H, I, J, K, L, and M, N, O, P. And in this case, the equation we're going to use is so from A, B, C, and D, instead of just the 2 points, will be equal to the minimum of the distance from A to B, the distance from C to D, so we've calculated those, and then we're going to add the distance from both of the previous lists. So we want something from A and B and something from C and D. Okay, so let's do this for real with actual A, B, C, D. So distance from A, B, C, D will be the minimum So the distance from A to B was 4. The distance from C to D was 4. And then we want something from both lists here. So we'll choose, in this instance, C and A. Okay, so that's going to be the square root of 2 minus 1 squared plus 4 minus 2 squared. And we chose those because those two are the ones that are closest together. So rather than iterating over every element in the list, we're taking the two that are nearest. Okay, and so then this is the minimum of 4, 4, and the square root of 5. So that's going to be equal to the square root of 5. Okay, so then we'll do the same thing for E, F, G, and H. So that's going to be the minimum of the distance between E and F, which was 5. The distance between G and H, which was 5 times the square root of 2. And then we'll take E and H, because they are the closest together, points that are in separate sublists. And so that's going to give us 4 minus 3 squared plus 3 minus 1 squared. And so that gives us the minimum of 5, 5 root 2, and the square root of 5. So again, the square root of 5 is the answer. We'll do the same thing for the distance of I, J, K, and L. So that's going to be the minimum of 3 square root of 10. Oops, I got ahead one. This is going to be 4 square root of 5. And then we'll take J and L. And so when we take the square root of 6 minus 5 squared plus 7 minus 5 squared, we get, again, the square root of 5. And so this is equal to the square root of 5. And then the last one, MNOP, that's going to be the minimum. So the distance between M and N was 3. Between O and P was square root of 10. And then we'll take points N and P. So we'll take the square root of 8 minus 7 squared plus 6 minus 4 squared gives us the square root of 5. And so again, our minimum is the square root of 5. Awesome. So we're moving right along, and by a similar fashion, instead of doing 4, we're going to cut into 8. So now we're splitting this list just right down the middle here. And to find the minimum distances, we're going to use the difference of A, B, C, D, E, F, G, H, which I'm just going to kind of shorthand as A through H, is equal to the minimum of the distance of A, B, C, D, the distance from E, F, G, H, and then, of course, the distance from the elements of both. One element from A, B, C, D, one from E, F, G, H that are the closest together. And so if we want to take a look at the actual A through H distance, the element that separates the two partial lists, the A, B, C, D from E, F, G, H here is going to be about x equals 4.5. And it's also, we want to note that the minimum, so this distance, the minimum between ABCD and the distance of EFGH well, these were both the square root of 5. So the minimum of those two is going to be the square root of 5. So when we are choosing a point from both, what we want is for the x-coordinate to be equal to 4.5 plus or minus the square root of 5, and also that the y-coordinates are have a distance of less than the square root of 5. So we're narrowing down elements that we're choosing here. And so when we do that, we get that this distance is equal to the minimum. So we had the ABCD of square root of 5, the distance from EFGH to be the square root of 5, and then we're also going to take points B and F. So that gives us the square root of 3 minus 1 squared plus 6 minus 6 squared. And so that is equal to 2, which is going to be our minimum here. And so then when we take on the second half, so now we're just going to worry about the I through P. In this case, the middle line here is going to be at about x is equal to 6.5. And so again, as we take the distance of I through P, the distance from I through L and the distance from N through P were both the square root of 5, right? So again, the minimum of those two then is going to be the square root of 5 since they're equal. So we want an x-coordinate to be roughly equal to 6.5 plus or minus the square root of 5 as we look for our third set of points to compare. And we want, again, for the y-coordinate to have a distance between them of less than the square root of 5. So that's going to narrow it down. And we'll choose I and M as having the shortest distance. So we choose those. So we end up wanting the minimum of, so the distance from ij, k, and l was root 5. Distance of m and op was root 5. And then we want the square root of, we're taking the distance from I and m. So that was 7 minus 5 squared plus 1 minus 1 squared, which of course is going to be equal to 2 as well. So lastly, we're going to do this whole thing, A through P. So it's a similar process. The line separating the two halves here is 4.5. And the minimum between the distance distances from the previous part, right? So those were both 2, 2, and 2. So we want an x-coordinate to be 4.5 plus or minus 2. And we want the y-coordinates of the points that we choose to differ by less than 2. And in this case, we can use h and I as having the shortest distance. So when we take the distance of this whole thing, we're going to get so the distance of the whole thing is going to be the minimum of the distance of A through H, the distance of I through P, and then the distance, and this time we are choosing for our 2 points H and I. Okay, so this ends up being equal to the minimum of 2, 2, and the square root of 5 minus 4 squared plus 3 minus 1 squared. And so the minimum is 2, because this here is going to be equal to 3. No, that's not right. That's going to be equal to, doing some quick math in my head, so 5 minus 4 is 1 squared is 1, 4 square root of 5. Okay, and so the total minimum is 2, which means we have a minimum distance between B and F, as well as I and M. Both have the shortest distance of 2. And we can always a good idea to double check that, right? So if you wanted to quickly say the distance of B and F is going to be equal to the square root of 3 minus 1 squared plus 6 minus 6 squared is equal to 2. 6's cancel out. Here we get 2, the square root of 2 squared. And then, of course, the distance between I and M is going to be 7 minus 5 squared plus 1 minus 1 squared. And so we get the same thing, 2. So these are the